CPU. CPU, or Central Processing Unit. The CPU is the brain of your computer. Every task you do, opening a browser, editing a document, running a game, goes through the CPU first. It processes instructions one after another, billions of times per second. Modern CPUs have multiple cores. Think of each core as a separate worker. A 6-core CPU handles 6 tasks at the same time. Clock speed, measured in gigahertz, tells you how fast each core works. A CPU running at 5 GHz completes 5 billion cycles per second. The two big players are Intel and AMD. Intel has the Core i3, i5, i7, and i9. AMD has Ryzen 3, 5, 7, and 9. For most people, a mid-range chip like an i5 or Ryzen 5 is more than enough for gaming and everyday use. Higher-end chips like the i9 or Ryzen 9 matter for video editing, 3D rendering, or running multiple virtual machines at once. Motherboard. The motherboard is the main circuit board that connects every component in your system. CPU, RAM, GPU, storage, power supply, they all plug into it. Without the motherboard, nothing can communicate with anything else. Think of it as the nervous system of your computer. Motherboards come in different sizes. ATX is the full-size standard with the most expansion slots. Micro ATX is smaller and cheaper, but still fits most builds. Mini ITX is the smallest, designed for compact systems. One critical detail is compatibility. Your motherboard has a specific socket that must match your CPU. An Intel 12th Gen chip needs LGA 1700. An AMD Ryzen 7000 needs AM5. If the socket does not match, the CPU physically will not fit. The chipset also controls features like overclocking support, USB port count, and how many M.2 SSD slots you get. So always pick your CPU first, then find a motherboard that supports it. GPU. GPU, or Graphics Processing Unit. The GPU handles everything visual on your screen. Games, video playback, 3D modeling, even the animations in your operating system. All processed by the GPU. Unlike a CPU with a few powerful cores, a GPU has thousands of smaller cores. This lets it process millions of pixels at the same time. That is why GPUs are so much better at graphics than CPUs. A modern GPU can push over 100 frames per second in demanding games while handling ray tracing and AI upscaling simultaneously. NVIDIA and AMD dominate this market. NVIDIA's GeForce RTX series is the most popular for gaming, with features like DLSS and hardware ray tracing. AMD's Radeon RX competes at similar price points, with its own upscaling tech called FSR. Intel entered with Arc GPUs, though they are still catching up. If you only browse the web and watch videos, integrated graphics built into most CPUs are fine. But for gaming or any GPU-heavy work, a dedicated card makes a massive difference. It is usually the most expensive component in a gaming PC. RAM. RAM, or Random Access Memory. RAM is your computer's short-term memory. When you open a program, the data it needs gets loaded from storage into RAM, because RAM is much faster to access. Close the program, and that data gets cleared. Think of it like a desk. Your storage drive is the filing cabinet. Pulling files out takes time. RAM is the desk surface, where you spread out what you are working on right now. Bigger desk, more things open at once without slowing down. Most computers today use DDR4 or DDR5. DDR5 is newer and faster but more expensive. For general use, 8 GB works. For gaming, 16 GB is the sweet spot. For video editing or professional work, 32 GB or more is worth it. RAM also runs at different speeds, measured in megahertz. Faster RAM helps, especially on AMD Ryzen systems. But the difference between 3200 MHz and 3600 MHz is small compared to just having enough capacity. Prioritize amount first, speed second. Storage drive. This is where your files, programs, and operating system live permanently. Unlike RAM, storage keeps data even when the computer is off. There are two main types: HDD, hard disk drive, and SSD, solid-state drive. An HDD uses spinning metal disks and a mechanical arm to read and write data. Slow, but the cost per gigabyte is very low. You can get 2 terabyte for around $50. The downsides are noise, heat, and fragility. An SSD has no moving parts. It uses flash memory and is dramatically faster. A computer that takes 2 minutes to boot on an HDD starts in under 15 seconds on an SSD. Programs open almost instantly. NVMe SSDs go even further. They plug directly into an M.2 slot on the motherboard and skip the older SATA interface. The speed difference between NVMe and a traditional HDD can be 20 to 30 times. Most people today use an SSD for their OS and programs, then add an HDD for bulk storage like movies and backups. Power supply you need. The PSU converts electricity from your wall outlet into the different voltages your components need. CPU, GPU, fans, drives. Each requires a specific voltage, and the PSU delivers the right amount through dedicated cables. Wattage is the main spec. A basic office PC needs around 300 watts. A gaming PC could need 650 to 850 watts. High-end systems push past 1,000 watts. If the PSU cannot provide enough, your system crashes under load or refuses to start. Efficiency ratings matter too. An 80+ certification means less electricity wasted as heat. Bronze is budget-friendly. Gold is the most popular for gaming builds. Platinum and titanium exist, but cost more than most people need. There are also modular and non-modular PSUs. Modular lets you detach unused cables, making the inside of your case much cleaner. Non-modular has all cables permanently attached, and never cheap out on a PSU. A bad one can damage every component in your system. CPU cooler. Every CPU generates heat when it works. Without a cooler, it would overheat and shut down within seconds. The cooler sits on top of the processor and pulls that heat away. There are 2 main types. Air coolers use metal heat sinks with heat pipes and fans. They are affordable, reliable, and basically maintenance-free. A good tower cooler from Noctua or Be Quiet can handle even high-end CPUs. Liquid coolers, also called AIOs, short for all-in-one, pump liquid through tubes to a radiator mounted on the case. They cool more effectively under heavy loads and look cleaner inside the build. But they cost more and carry a small risk of leaking. Though modern AIOs rarely have that problem, most CPUs come with a stock cooler in the box. For basic tasks and light gaming, the stock cooler works. But if you push your CPU hard with rendering or overclocking, an aftermarket cooler keeps temperatures lower and your system quieter. Case fans. Case fans move air through your computer case to keep everything cool. Without airflow, heat builds up and your components throttle. They automatically slow down to avoid damage. Over time, excessive heat also shortens hardware lifespan. The standard setup is intake fans at the front, pulling cool air in, and exhaust fans at the back and top pushing hot air out. This creates a path that moves heat away from your CPU and GPU. Fans come in different sizes. 120mm is the most common. 140mm fans move more air at lower RPM, so they tend to be quieter. Most cases ship with 1 or 2 fans, but adding at least 1 more usually helps. For most builds, 2 to 3 fans total is the sweet spot. Going beyond that gives diminishing returns. The difference between 3 fans and 6 fans is usually only 2 to 3 degrees. Unless you have extremely hot components or a case with restricted airflow, extra fans are not worth the extra cost. Computer case. The case holds all your components together. It protects everything from dust and damage and provides mounting points for the motherboard, drives, PSU, and fans. Cases match motherboard sizes. Full tower fits ATX and has the most room for large GPUs, multiple drives, and big radiators. Mid-tower is the most popular and fits ATX and micro ATX. Mini ITX cases are compact but leave little room for cable management or long graphics cards. Airflow matters more than looks. Mesh front panels let air flow freely. Solid glass fronts look nice but trap heat inside. Always check GPU clearance before buying. High-end cards can be over 300mm long, and not every case fits that. Some cases include fan hubs, cable management cutouts behind the motherboard tray, and toolless drive bays. Nice features, but they do not affect performance. Pick a case that fits your board, supports your GPU length, and has enough fan mounts. Everything else is preference. Network card. A network card, sometimes called a NIC, short for Network Interface Controller, connects your computer to the internet or a local network. Most motherboards already include a built-in Ethernet port and often Wi-Fi too. So the majority of people do not need a separate card, but sometimes you do. If your motherboard lacks Wi-Fi and running a cable is not an option, a PCIe Wi-Fi card solves that. If you need faster networking like 5 gigabit or 10 gigabit Ethernet for a home server or NAS, a dedicated card provides that speed. For gaming, wired Ethernet is always better than Wi-Fi. Lower latency, more stable speeds, and no interference from walls or other devices. If you must go wireless, make sure your card supports Wi-Fi 6 or 6E. These newer standards offer faster speeds and handle crowded networks much better, where multiple devices compete for bandwidth. Sound card. A sound card processes audio for your computer. It converts digital audio data into the analog signals your headphones or speakers actually play. This conversion is handled by a DAC, short for digital to analog converter. The reality is that almost every motherboard made in the last decade has built-in audio good enough for most people. YouTube, Spotify, gaming with a headset, onboard audio handles all of that without issues. Dedicated sound cards exist for a specific audience. Music producers who need clean, low-latency output for studio monitors. Audiophiles with high-impedance headphones that need more amplification than onboard audio provides. For these users, a dedicated card or external audio interface is a real upgrade. For everyone else, the money spent on a sound card is better invested in better headphones or speakers. Upgrading from a $30 headset to a $100 one makes a far bigger difference. That is why most modern builds skip the sound card entirely. Optical drive. An optical drive reads and writes CDs, DVDs, and Blu-ray discs. 10 years ago, every computer had one. Today, most builds skip it. The reason is simple. Streaming replaced physical media. Games download digitally through Steam or Epic. Software comes as downloads. Operating systems install from USB drives. There is almost no everyday reason to have one. Some people still need them. If you rip old CDs, install legacy disc-only software, or work with Blu-ray video production, an optical drive is useful. External USB optical drives solve this perfectly. Plug it in when needed, store it when not. Around $20 to $30. For new builds, leave it out and save the drive bay. On the rare occasion you need disk access, an external USB drive handles it without taking permanent space inside your case. Expansion cards. These are add-on components that plug into your motherboard's PCIe slots to add new features or upgrade existing ones. Your GPU is technically the most common expansion card. Beyond that, there are Wi-Fi cards, sound cards, USB expansion cards that add more ports, capture cards for streaming and recording gameplay, and RAID controllers for managing multiple drives. PCIe slots come in different sizes. X16 is the longest with the most bandwidth, almost always used for the GPU. X4 and X1 slots are shorter and handle everything else. The number refers to how many data lanes the slot provides. More lanes means more bandwidth. Most home users never need expansion cards beyond a GPU. Modern motherboards already include Ethernet, Wi-Fi, audio, USB ports, and M.2 storage slots built right in. Expansion cards are mainly for professionals, content creators, or enthusiasts who need something specific that their board does not have. BIOS, UEFI chip. BIOS, which stands for Basic Input-Output System, is the first software that runs when you press the power button. Before Windows loads, before any driver kicks in, it wakes up your hardware, checks that everything works, and hands control to the operating system. UEFI, which stands for Unified Extensible Firmware Interface, is the modern replacement. Almost every computer after 2012 uses UEFI. It does the same job but with a graphical interface, mouse support, faster boot times, and support for drives larger than 2 terabytes. Something the old BIOS could not handle. The firmware lives on a small chip on your motherboard. Press Delete or F2 during startup to access it. Inside, you can change boot order, enable XMP or Expo to run RAM at rated speed, adjust fan curves, and monitor temperatures. Most people rarely touch it after setup. But if you build your own PC, install a new CPU, or overclock, this is where all those settings live. Anyway, I also made some other cool videos too. Don't forget to watch them later. Okay,